We are going to now move on to Graciela. So Graciela is a professor of chemistry at the University de Los Andes in Venezuela. Her
handheld models and pass around the class.
Diffraction for the characterization of materials, including organic, inorganic, hybrid porous materials with potential applications in
the wonderful team.
The exec committee at the IUCR, International Union of Crystallography, and a section editor of Actuary, and she's a passionate educator.
So I know some molecular structure.
Graciela is going to be telling us more about her use of crystallographic databases in teaching.
With me, but I learned that
So we're delighted to have you, Graciela, and it's over to you.
Molecules in mercury.
Thank you very much. Can you hear me?
We can, and we can see.
Okay.
Important too.
Well, thank you very much for the invitation to talk.
So introduce me to the
meeting. I'm very glad to
lower level chemistry. Also,
just present.
Introduce us.
Actually, do here when we try to teach crystallography to students in our.
I had to go online.
First, I would like to
including soft hard copy.
Just highlight
and I got enough
historical things about crystallography in Latin America. It's not meant to be a complete historical recount of crystallography in Latin America, but just to point out some
paper, and it has
interesting. It seems that
well as structural chemistry too.
Most of our knowledge, the Argentina is
the page. I found this interesting
that started with
Professor
at Universidad de Buenos Aires in Argentina.
Resources for teaching chemistry.
This was a work in the.
I found a lot of structures that
Ernesto Galloni, who carried out studies in
reality and a whole lot of
Argentina, and for example, he
solved most of
in 1934. In 1947,
fluorocobalt 2
from the Institute of Physics at UNAM in Mexico,
illustrate tetrahedral mercury I could wrote
by B.E. Warren, but Bertrand Warren.
They see the molecules
to Mexico. He
in my illustrations
crystallography course that he started to teach in the
to pass my structures around.
And then in 1949 they purchased
beautiful structures and we could
X-ray diffraction instruments. One of his students, Octavio Cano Corona, is considered the pioneer of crystal
subset. I got a lot
in Mexico. Brazil has certainly been one of
these three molecules of the C2 symmetry
in Latin America. Brazil is the first country and the only one that has installed.
Also have the molecular plane.
And there is one that just
in this molecule
work a very new the second light source that synchrotron light source that started to work in Brazil. So it's and one of the interesting interesting parts is that since the first source they designed, they made a lot of the components, so it implied a lot of work also from the technical point of view. There was a very important school in Sao Carlos in 1974 on direct methods, and it was attended by very famous invited speakers like Wolfson, Jerry and Isabella Carle, Herbert Hauptmann, P.P. Eval, Maine, and among other invited speakers. So that's one of the landmarks activities in Latin America in crystallography. In Chile,
beta carbon bond.
1952, Naum Joel founded an X-ray laboratory at Universidad de Chile.
Ferrocin.
Founded another one in Concepcion. They had worked at Birkbeck College with J.D. Bernal, and when they returned, they set up these facilities there.
Conquest is the ability.
Important school in Santiago that was sponsored by UNESCO in 1959, and this is also regarded as
and for
crystallography events in Latin America. In the late 1950s, Stephenson Katisha Ellis, who had been at University of Glasgow and at Cavendish Laboratory in Cambridge, and Sven Furberg from crystallography in Uruguay. And in 1967, Katisha Ellis published some work in Acta Crystallographica. After that, Raúl María Escurrena and Adolfo Amit, among others, continued.
Once they read about this,
60s, and that has continued since then. Other countries that have developed crystallographic facilities, or at least
where we measure,
had some kind of activity in the region, are Colombia for some time, more recently Ecuador, Peru, Bolivia, Guatemala,
and get to understand why
they have established a very good laboratories, and they have even applied, and they were accepted as one of the member countries of the International Union of Crystallography. And Colombia and Guatemala are in the process of also becoming
the CSD.
This is just a few things that
but in 2017
in Venezuela we owe the start of crystallographic studies to
and I have
researchers that came to work in Caracas at Universidad Central. And also one person who carried out studies in this university in Caracas is Professor Eldris Rodulfo de Gil. She moved to Venezuela in 1969 to found the laboratory where I work, and we will celebrate our 52nd anniversary this year. She had carried out studies, PhD studies at the University of Wisconsin with Professor Larry Dahl. And one of the structures that she
really
is reported with a ref code that I'm showing here. Soon after the department was established, one person, Valentina Rivera, graduated with a thesis in crystallography, and she then carried out work with
thank you for the
Sheldrick in Cambridge. And some of the first structures that she reported have also these ref codes in the CSD. We had one major event in 1990. It was the Ibero-American meeting and the
virtual learning
crystallography, where we had the pleasure of having very distinguished invited speakers. Here we have Dr. Herbert Hauptmann, who came with Bill Duax as invited speakers for the school and the meeting, Fernando Laos from Spain, and Angel Vegas Molina from Spain. We also had Professor Bernie Winch from MIT, Bob Snyder from Alfred University, Georg Will from Germany, Bruce Fox,
I think
Brandeis University in the US, and one Venezuelan crystallographer who moved
them to really have a feel
and did his career there, who is Javier Isern. And here, Professor Eldris and Valentina, the two persons that we consider the founders of our group. In this picture, there are people who attend
crystallography, but I read a lot
from very good crystallographers and that have continued to carry on. For example, Daniel Vega from Argentina, also Professor Jose Antonio Henao from Colombia, who is now a very close collaborator. Lauro Bucio was a student at the time, but he continue working at UNAM and has become also a very well-recognized figure in Mexico in crystallography. So we consider this a very important event for Latin America. Well, when I did my PhD work at Brandeis University, we didn't have the CSD as we have early, not even in the early 1990s. But from 1992 and 96, when the CSD started to be distributed in magnetic tapes, we distributed to
just asking them to build.
We copy the tapes, the manuals, and we send them to laboratories in Mexico, Argentina, Brazil, and other places. Later, it came in cartridges, and it was a little bit easier, but still it was quite a task at the time. I visited the CCDC in August of 1993 on the way back from China, from being at the IUCR meeting in Beijing. And I had the opportunity to visit the new headquarters. And here is a picture with Sam Motherwell and with Dr. Olga Kennard, who hosted our visit. I went with my husband, Miguel Delgado, who is also a crystallographer. So it was very nice to visit and to meet the people behind the CSD that at the time relied a lot on copying the information from publications to the database. Well, we were able to afford the CSD for several years, and at some point after a school that we had in Caracas, where among other invited
just drew the
thing Martinez Ripoll from Spain, we had access to the CSD through a big project that Spain, the Ministry of Science of Spain, had and provided access to the CSD
in their career is
Latin America. More recently, due to economic hardships, we had also troubles with the CSD. But through the Frank Allen International Research and Education Program, the FAIR program that Samuel mentioned, we have been able to have access to the CSD, and we are very, very grateful to the CCDC for providing that opportunity.
Put them in.
Okay, well, our chemistry studies are very have a very strong influence from I would say classical chemistry studies, and it's very heavily some areas are more heavily represented than other ones. For example, analytical chemistry and organic chemistry is very we have many courses in these areas, and a lot of that is also directed towards this solution in liquid state, not too much into the solid state. But we have optional courses that students can take, and we have an undergraduate degree thesis project that has to be done over a period of 2 semesters. And with that, well, we have the opportunity to encourage some students to work in crystallography. We, of course, use the books like the book that Bill Clegg presented yesterday. That's one of the, it's very, very, and I'm book for undergraduates and also for graduate degree students. But Miguel and I, we have written some notes to make it a little bit easier. A few things that we use, introductory courses for people who is not familiar with crystallography to start this kind of work. So in the optional course, we have some basic topics as other crystallography courses, and we have several opportunities, a few in teaching, for example, the representation of symmetry elements, to simulate powder patterns, and search by diagram, by name of the compound, by author, and also use the exported CIF to make additional representations of the molecules, or to do more recently Hirschfeld surface analysis and energy framework calculations. So these features, first country in Latin America, some of the features that we use a lot, the possibility of seeing, for example, the planes, the glide planes, mirror planes in the structure, and also screw axis and the inversion centers, for example, related to the compound that we are studying. That's very important for the students. And also the possibility to export the XYE data to reproduce the powder patterns and use them in other databases, such as the ICDD powder diffraction database. So what we try to do is to go from having a powder, for example, how to mount it, how to collect the powder diffraction pattern, do some identification by search match procedures with the ICDD database, and identify the compound. For example, in this case, we have clenbuterol received from a pharmaceutical line. They purchase, have the data that is in the PDF4 that is calculated from CSD entry from this one. After some treatment, we obtain, we dissolve in different solvent and submitted this compound to different conditions and obtain a new phase of clenbuterol that we solve using DASH. We also sometimes check with other programs, but basically with DASH, and TALP has also been a successful program to use. And with regard to single crystal, we have a similar procedure, and we try to go through this flow diagram to help students understand all the processing parts. Is that laboratories, for example, the organic chemistry laboratories, they have a lot of synthesis, and there is one very advanced organic chemistry laboratory that sometimes provide an opportunity to a point of view more than just the chemistry laboratory. In this case, for example, the students have been doing for a long time, have been preparing the same compound, and one student realized that the compound that he made, this compound, Isabella Carle, characteristics that other students reported, for example, the melting point. So it turned out to be a new polymorph of this compound, and we were able to publish that. In this case, for example, this around 1950 in the XOXO form, and also as a result, and Francisco Guido Canepa, we were able to solve the structure and repair another one in Concepcion. More recently, we have been working with pharmaceutical compounds that we receive. They return the laboratories here in Venezuela, and one of our students got interested, a very young student who actually did some work from high school in our lab. She got interested in this compound, Flunixin, and it turned out that it's related to 1950s in the CSD database, and has shown to be found in 4 polymorphic forms. So we obtained the data from the database, and that helped us a lot in studying our compound. We solved the structure first from powder, using TALP and DASH, but then we obtained single crystals that were appropriate for solving the structure. But here, for example, we have been using the facilities that Mercury has for superposition of the molecules. This is, for example, the Flunixin molecule in form 1 with clonixin form 1, which we identified are similar. This is a structure of the compound, and we analyzed the hydrogen bonding patterns, but the facility that Mercury has for identifying hydrogen bond patterns through the graph set symbol that ether et al. Developed works very well, actually. We were expecting at some point a sweeter ionic polymorph, but we haven't found it yet. But we are trying to use different solvents to see if we can find it. We also identified a different polymorph, a second polymorph, and here is the superposition of the molecules of the first one and the second polymorph. And we see that it is closely related to, actually forms a form of clonixin. Here is a view of the structure, and we see that the hydrogen bonding pattern is different. And also with the help of mercury, we were able to identify also the hydrogen bond patterns there. And another thing that we have been using a lot is the hydrogen bond propensity analysis, and in this case, it predicts very well the hydrogen bonding patterns in the 2 polymorphs of Flunixin and the 4 polymorphs of clonixin. And with the SIF data that we obtained from the database, we used to carry out calculation with Crystal Explorer, and we identified that in fact Flunixin polymorph 1 is closely related to clonixin form 1, and the form 2 is more closely related to form 4. And we published this last year. So we try to use the database in different settings, trying to help the students. And these are just some pictures of schools where we have presented the CSD and all of the components. We had one major recently, the third LACA school, under the circumstances had to be carried out in a virtual setting, but it was actually very, very successful. And these are some meetings that we have organized in Colombia. To this one in 2017, we had the opportunity to host the visit of Amy Sargent while she was at CCDC, and this was the most recent LACA school in 2019 in Colombia. This is part of our group, a few current former students, and these are former graduate students that that we had the opportunity to see in Colombia in 2019. So we have to acknowledge our collaborators from Colombia, from Indiana University, Northwestern University, the laboratories in Venezuela that provide some of the pharmaceuticals, and certainly we are very grateful to the CCDC for the access through the FAIR program for ICDD. I just wanted to finish by saying that Acta Crystallographica E is receiving contributions that are related to teaching crystallography. Here are some of the ones that are related directly to teaching. One by Bill Clegg, by Tom Speck, Anthony Linden, working at UNAM, and crystallographers that are publishing the work in ACTA-E with the new and also experienced crystallographers in this area. So I think with this, I'm just about maybe 2 minutes. Took 2 minutes of the coffee break, but I wanted to show some of the things that we have done and that we like to do and that we enjoy to do. So thank you very much again for the invitation.
Thank you for a lovely talk, a journey through crystallography in Latin America, and it's really nice to see the variety of ways you're using structural chemistry in education as well, and the CSD. Has anyone got any questions for Graciela before we go to the coffee break? Again, if you want to post any questions in the chat box or turn your cameras on or ask verbally, you're welcome to do so. While people are getting their questions ready, I had a question. So you clearly do quite a lot of crystallographic education. Is it common for undergraduate students to learn about crystallography in Venezuela, or?
They want to learn. They are not too too much trained into the solid state, but once they encounter crystallography, we can grab their attention and even also encourage some students to speakers. We had in our laboratory. So that has worked well, and they particularly enjoy working with the databases, the CSD, and all the components that it has, and also with the ICD access, the powder diffraction database. And we are also we try to encourage using the best facilities from each one and try to combine them to be able to the FAIR program that someone that they are working is has been. We have been able to before. Or if related compounds have been reported. One thing, for example, with the people from natural products, they sometimes they consider that it is a known compound because it has the IR, NMR data have been reported, but we say, as you know, if it is not in the databases, you don't know the structure. So there is a lot of work that you can do there.
Did you have a question, Bill?
Well, it's not so much a question as a comment. Just following on from what you've still got displayed there, those articles on education in Acta E were actually write-ups of talks given at the European Crystallographic meeting in Vienna in a session that we called Teaching New Dogs Old Tricks.
Exactly.
The three general interest groups of the ECA, that's the senior crystallographers, which I chair now, and the young crystallographers and the education group are all trying to work more closely together.
Miguel and I, we have
and that we have plans for the next ECM, which should have been
introductory courses for
presumably going to be next year in
to start this kind of
and it's proved very popular. And I think that's the sort of thing that could be done at other conferences. Just sessions where those with years of experience,
all the representation of symmetry,
pass on that experience to younger people who are enthusiastic but can learn some tricks.
Except by diagram, but by name. To see more papers on that that can be helpful to newcomers and also to experienced crystallographers who
Indeed.
for the first time encounters something with I don't know, strange twinning, are very like that.
And I guess not everyone can go to the conferences, so trying to make that learning more accessible is really important. We are going to take a break now, so if
screw axis and
past the hour, when we'll come back and we'll hear from Ilaria
to reproduce the powder pack
before closing. So thank you again, Graciela. I'm sure Graciela will stay online if there's any other questions that come up, and we'll see you after the break.